We are in the Prudential Physics and Mathematics Lyceum number 239, St. Petersburg, Russia. I am Garbola Danil, the programmer and the captain of the Double D team. Here is the constructor and electronics engineer Popov Danil, working as a cameraman. I and my teammate have been in robotics for at least 6 years, and 2 years of which were in VRCap competition. We have got a lot of skills and experience during our participation in VRCap, so we want to thank organizers of all VRCap competitions, our sponsors and our mentors. During our past participation in VRCap, we created a robot, one of the main devices of which was an OpenV programmable camera. It was a unique feature of our robot because it had been following a line, detecting green marks and finding victims thanks to that camera. As a result, we took the 4th place at the Russian stage and 7th place at the VRCap Asia Pacific 2019. It was the best result of Russian teams in Risk Line League in this competition. In our opinion, it was a good result considering lack of experience in VRCap and usage, difficult to learn devices, but I think we could do better.
Our robot consists of many elements, like a direct platform with a metallic frame, a motherboard, a microcontroller Mega 2560 Pro Mini, a robotic arm, and OpenV programmable camera. Let's start with a robotic frame. It's designed in CAD system Autodesk Inventor Personnel, like all other details in our robot. After design, it was cut on CNC milling machine, so, as I said before, the platform is tracked. In our opinion, it's the best choice because the robot can overcome obstacles better than robots with wheels. Our robot is driven by 2 DC motors that are powered by 12 volts. There is a motherboard placed on top of robot's platform. It was designed in deep trace software. As you can see, there is some groups of pins and cleats on the motherboard. For example, these groups are digital pins. This group is for connecting servo motors. There is cleats for DC motors placed on the side of motherboard. Motor drivers are right on the motherboard, which allow to save a space on the robot. To sum up, this board is designed for more convenient connection of peripheral device to main controller RoboDune Mega 2560 Pro Mini. Despite the size of microcontroller, it has a huge arsenal, 54 digital pins, 4 UART interface, I2C, 7 interrupts. Whoa! We use this microcontroller to control all the components of the robots, DC motors, sensors, servo motors and camera. We choose this board because it's faster than most Arduino boards, it has a lot of pins, it's small, which is important because we don't want to create a huge robot. In our opinion, it should be compact. In front of our robot you can see 3D printed robotic arm with 3 degrees of freedom. It is driven by servo motors with a torque of 3 kg per centimeter. A tongue is used as a walking body to take any kind of spherical and cubic objects. Also, the Python programmable camera OpenV Cam H7 placed in front of the robot. As it was already man-shot, robot used this camera to follow a line, detect green marks and victims. It has some digital and analog pins, 2 UART interface and I2C interface.
Now I will show you how does our algorithms works. This is one of the VRCap's 2-line polygon options through which our robot must pass. The main idea of an algorithm is to split an image into a grid and search for a black color in each cell of it. If there is too many black in a cell, there will be one image describing matrix, at the corresponding coordinates, else 0. After checking all the cells, we will have the field describing binary matrix and it will be used for line following and green matrix detection. For the first one, at the beginning of the program, a new matrix is creating with the same width and height, but its values are angles between the y coordinates axis at the middle of an image and a line from the local 0 to the center of a cell. After that, these matrices are multiplying and the result is a matrix with non-zero angles. That is, only these angles, there is a black line, and then I'm just finding average between all non-zero values. In the result, we have only one value, deviation from a line. For the second, that is matrix detection, the binary matrix is used for finding coordinates of line's bottom. We need it for building a region of interest. There, a linear regression algorithm will work from standard OpenMV library. In simple words, the linear regression algorithm is about finding a line corresponds to all points as close as possible. So, this algorithm used for correct matrix detection when our robot drives into an intersection at an acute angle. Initially, our algorithm for matrix detection looked like this. When there is a green area on an image, the pixel values were read from above and to the left of it. Only if the pixel above the area is black, there was a check of pixel to the left of it. If it's black, the robot must turn to the right, else to the left. Such an algorithm takes place, but what if the robot will be in a situation like this? There will be errors. The algorithm still checking above and to the left of the area, but there aren't real top and left sides. To correct an angle error, I am using the linear regression algorithm I'll talk about earlier. It returns an angle between x-axis and a perpendicular to the line created by the algorithm. After that, I can fix the coordinates of pixels the color will be read from with these trigonometric formulas. Sounds complicated, and that's the way it is, but the code has optimized, so the FPS values are about 20, which is a good result considering many calculations and the fact that in the previous code this value was about 12. Also, the increase in FPS confirms the words about gaining an experience said at the beginning of the video.